Okay, so I wanted to talk a little bit about discovering quadratics, or in other words, the fundamentals and the basics of quadratic functions in terms of solving them and doing things like graphing them. So there's a couple things that you need to know, or that you need to focus on before you actually attempt to solve or graph a quadratic function. And that is, again, that your standard form must always be ax squared plus bx plus c. Now the other thing about quadratics to remember is that they've got this parabola shape. So again, that's a U shape, and when your arrows point towards the top of your page, this means you have a positive parabola. If your arrows are pointing down to the bottom of your page, this means you have a negative parabola. Okay? So when we talk about characteristics, we usually are talking about them in terms of the a value. Well, if you notice, a is the coefficient attached to the x squared. So if that term is greater than 0, meaning positive, it opens up. And if it's less than 0, meaning negative, it opens down. Now the other thing that we keep in mind is we have this new term here called the vertex. The vertex is that single point in which your parabola changes its direction. So it either goes from decreasing to increasing, or it goes from increasing to decreasing, but it is the single point where you change direction. And we refer to that as a max or min point. So if you look at a positive parabola, you see that it's a U shape. Well, it kind of looks like a valley. So therefore, this one would have what's called a minimum vertex. Okay? For a negative parabola, notice it kind of looks like a hill or a mountain. So that means this one has a max vertex. Okay. Now with those, we also have what's called the vertex formula. And the vertex formula says that we're going to find a point, because your vertex is always a coordinate point. And in order to find the x value, you have to do negative b over 2a. Well, you're going to pull a and b out of standard form. So what you have to remember is that a and b are the coefficients in the quadratic equation. So these are the coefficients attached to your x term in that quadratic equation. Well, to find y, we simply have to evaluate with that x value. So in other words, the y here is found by doing, say, f of x, where x here is going to be whatever you found in the first step. Now, in order to graph, there's a few things that you have to remember. First, you need to determine if the graph is going to open up or down. Okay, so again, remember, you're going to look at your square term and you're going to ask yourself, are you positive or negative? Second thing you have to do is find your vertex point. Okay, because you need to know which point are you changing directions. The third thing you want to do is you want to find any x-intercepts that are going to occur. So you need to remember that x-intercepts are where your graph is crossing that x-axis. The fourth thing you need to do is find your y-intercepts, because you need to know if your graph is crossing that y-axis at any point. And then finally, the last thing you can do is you can graph those points and finish out creating your picture. Now, if needed, always remember that you can create an XY table in order to find all the points in which to graph. So let's take a look at an example here. So the first thing I have is to graph the parabola using what's called that 5-step method. So that 5-step method are those 5 points that we just went over. And so this is how it works. Well, first thing to note is that my equation here is in standard form. Therefore, the first thing I want to do is I want to identify my A, my B, and my C. So here, A is my coefficient attached to x squared, and it's a 1. My B is the coefficient attached to my x term, which is a 2. And my C is the constant, -3. The pieces that are the most important for solving our problem are going to be the A and the B. So we have to look at setting this up. Okay. So first and foremost, we need to know, how are we going to open? So is my A term positive or negative? Well, in this case, it is positive, which means we are going to open up. So that is the first step, is knowing the direction of your arrows. The second step here is that we need to find your vertex. So to find the vertex says we need to use the vertex formula. The vertex formula is that x is found by -b over 2a. So we have to input b and a and reduce. So b was 2, so this becomes -2 over 2 times my a, which was 1. Well, 2 times 1 is 2. -2 over 2 is a -1. Now we have to find your y, which remember is going to be f of my x, and my x was a -1, which says in my equation up here, anywhere that I had an x, I need to input -1. So this becomes -1 squared plus 2 times a -1 minus 3. So -1 squared is 1. 2 times -1 is a -2. So I have 1 minus 2 minus 3 gives you a -4. So my vertex point here is going to be the point -1, -4. Okay. So now the third thing that we need to do is we need to look for any x-intercepts that we may have. So to do that, it means we need to take our equation and we need to solve the quadratic. So 0 is equal to x squared plus 2x minus 3. We can solve this equation by factoring. So again, create your factors. X squared breaks into x times x. Remember, this back term tells you what your signs have to be. So to multiply to a negative means I have to have one positive and one negative. And now I need factors of 3 that will give me a positive 2 as a result. Since my middle term is positive, it means the bigger factor must be positive. Therefore, I've got a positive 3 and a -1. To find the intercepts, says I gotta then take each part and set it equal to 0 and solve. So here, x is -3, x is 1. So this means I'm going to have intercept points written as an actual intercept. So here, this tells me that I have the point -3, 0, and I have the point 1, 0. Now the next thing that we need to do is we need to look to see if there are any y-intercepts. So this means every x has to be 0 and solve for y. So y is going to be 0 squared plus 2 times 0 minus 3. This tells me that y is negative 3, which is going to give me an intercept point, and in this case that intercept point is the point 0, negative 3. So we need to go ahead and graph the points that we have. So first we can start with your vertex point. So that's at the point negative 1, negative 4. So I'm going to go over 1, down 4. 1, 2, 3, 4. So that point is right here. And then I have the x-intercept points. So this is at the point negative 3, 0. So 1, 2, 3 puts it right here. And then at the point 1, 0. So over 1, 0 puts it right there. And then the last thing that we have is we have the y-intercept, which is at the point 0, negative 3. So 0, 1, 2, 3 puts it right here. So now what you just simply need to do is we need to connect these dots in order to actually graph our graph. So we would go ahead and you'd start at your vertex, and you'd graph up through your points and continue on up, and then do match through the other side. Up through your points and continue on up. And there you have your first quadratic. So now let's do it again. And so here, notice my a term is negative. Okay. So again, I can look at A, B, and C. My a term is a negative 2. My b term is 6. And my c is 20. Remember again, the most important pieces we need are these first two pieces, the A and the B. C is just kind of along for the ride. So I need to look at how does it open. Well, here my A term is negative, means I'm going to open down. The next thing that I need to look at is your vertex. And I'm here in standard form, which means again I have to use that vertex formula. So the formula says that x is equal to negative b over 2a. My b is 6, so this is negative 6 over 2 times a negative 2. Negative and negative becomes positive. 2 times 2 is 4, so this is 6 over 4. But remember, you always have to reduce. So when we reduce this down, this becomes 3 over 2. And with this one, now we're working with a fraction. So you need to be very careful. In order to find y, says I have to input my fraction. So this becomes negative 2 times 3 over 2 squared plus 6 times 3 over 2 plus 20. So we need to start reducing. 3 over 2 squared says you square the top and you square the bottom. So this becomes 9 over 4. Plus 6 over 2 reduces to 3, and then 3 times 3 is 9, plus 20. If we look back at the beginning again, it's still going to be negative. 2 over 4 is going to reduce to put 2 on the bottom. So this becomes 9 halves plus 29. And so then we need to combine these. So when you're trying to combine your fractions, you need to remember that you need a least common denominator. So here, that LCD is going to be 2. Because it's going to be 2, this means our equation is going to become negative 9 halves plus, and we have to multiply 29 by 2, which gives you 58 over 2. When we subtract 9 away, this is going to leave us with 49 over 2. And since that does not divide out evenly, that's how it stays. So when we're looking here at my vertex, in this case, I have 3 halves and 49 over 2. Okay. Now, for graphing purposes, sometimes it's smart to know what that decimal roughly comes out to be so that you know about how to graph it. And so this is the same thing as having 1.5 and 24.5. But in most classes, if you are doing this for a homework assignment, the fraction is what we want to see. Okay, so here, this would be the vertex that you would use. You would only use the decimal to help you actually create your graph. Okay. Now, the next thing that we have to do is we have to look at the x-intercepts to see if we have any. So again, this means that we need to solve the quadratic. So 0 is equal to negative 2x squared plus 6x plus 20. Again, we're going to solve this. Well, if you notice, I can pull a 2 out of all of these. So 0 is equal to x squared minus a 3x minus 10. So if you look, notice I divided my negative out to try and make things a little bit simpler. And then I also was able to pull out that 2. Now I can easily factor this. So I can create my factors. Again, x breaks into x and x. My sign here is negative, so I need one positive, one negative. My middle term is negative, so that means the bigger factor, it has to be negative. And in this case, factors of 10 that will give me 3 have to be 2 and 5. So 2 is positive, 5 is negative. You're going to set each part, so x plus 2 equals 0, and x minus 5 equals 0. You're going to solve them. So here you get that x equals negative 2 and x equals 5, thus giving you the coordinates negative 2, 0, and 5, 0. Now the very last thing that you need to look at is your y-intercept. And in this case, it means anywhere you have an x becomes a 0. So to do that y-intercept, says y is going to equal negative 2 times 0 squared plus 6 times 0 plus 20 gives me 20 as a result. It means the intercept value here for your y-intercept is the point 0, 20. Okay. So now we have to graph it. So notice I don't exactly have 20 graph points. So you can go ahead and make your graph or make your coordinate graph fit the graph or points that you need. which is perfectly fine. And so here I might go ahead and say that if I'm doing this, I have 5, 10, 15, 20, 25, okay? So count up by 5s. So 5, 10, 15, 20, 25, 30, and so forth. And so therefore, when I'm looking first at my y-intercept, I've got the point 0, 20. So I'm going to go ahead and put that in. So 0, 20 would fall right here. And then over on the other side, I may go ahead and make this be 1, 2, 3, 4, 5, 6, 7. So it's going to be a little bit kind of distorted, but that's okay. I have a vertex that occurs at the point 1.5, 24.5. So I'm going to go over 1.5, and I'm going to go up to just slightly below that 25 mark. I then have x-intercepts at 5, 0. So I have one right here. And I have another one at -2, 0. So that would be right here. And so then I could go ahead and just draw my parabola. And because I labeled my coordinate plane with my values, that's what makes this a legitimate parabola to match the problem. If you would just simply slap this on without labeling it, we wouldn't know, or nobody would understand what you were doing, and the graph would not necessarily match what your equation was. So those are a couple examples on graphing quadratics when you have standard form using that vertex formula.